So first of all, we try to understand this problem, and then we will see some test cases, and then we will see the approaches. Okay. So like what the question is saying, you have given an permutation from 0 to n minus 1. Okay. You have given an array which contain the element from 0 to n minus 1. You have given us array of size n, and you have to arrange the element of the array in a such a way. You have to arrange an element array in a such a way such that ai plus I is a perfect square. Okay. So if you see this example, okay, if I show you this example, 102. So basically, if the value, so basically, if you see this, it's 0, 1, 2, and if you see this 1, 0, 2, this is index, this is a of I. So if you add this 0 plus 1, it will 1. The 1 is a perfect square. If you add this, 1 is also perfect square. If you add this 4, you will get also perfect square. So basically, if you arrange this element in a such a way, in this way, you will get a perfect square. So if this is the test case 0 to 1, 0 plus 0 is 0, and I will add 3 with 1 because the index is 1. I will get 4. I will add 2 plus 2, 4, and if I will add 3 plus 1 plus 3, 4. So like all the element are perfect squares. So the answer will this is the this is a correct permutation. This is also correct permutation. And if you will perform the operation for this, you will also get a all number as a perfect square. Okay, like 1 plus 0 is a 1, also perfect square. 0 plus index 1 is a perfect square. 2 plus 2 is a perfect square. 6 plus 3 is a 9, which is also perfect square. 5 plus 4 is 9, is also perfect square. 4 plus 5 is also is a 9, is also perfect square. 3 plus 6, 9 is also perfect square. Okay. So you see, like this array is also, like if you add this all element of the array to the index, you will also get a perfect square. Okay. So you have to form this, you have to build this permutation so that it's, if you add that if you add the element of that permutation to index, you get perfect square at every index. Okay. I hope the problem is pretty clear to you. Now we will see its approach. Okay. Uh, okay. Now we will see the approach. So how? If like if I will give you a random number, uh, 11. Okay. So how many how many number are there? So basically 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now what you have to do, it is a bit annoying. Now what you have to do, you have to arrange this indexes in a such a way, when you add this number to its index, when you add this number to the index, you will get a perfect square. Okay. So if you will see what I have to do, I will just use a greedy approach for it. Like like just example, if this is these are the index, just take an example. These are the index 0, 7, 8, 9. Okay. If these are the index, okay, so how much I will add to all this number so that I can get a perfect square? I will think like this. Okay. How much I will add to these index? Like just example, these are index and these are AI. Okay. And how much I will add from these number, this indexes, so that I will get a perfect squares. So basically, if I will see this a 10, I have to make this 10 as a, I will move like this. Okay. Uh, I have to now, what I have to do, this is the index 10. What I have to do, I have to make this index 10 as a perfect square. So basically, like what are the perfect squares? 0 is a perfect square, 1 is a perfect square, 2 is a perfect square, 3, sorry, 2 not is 4 is a perfect square, 9 is a perfect square, 16 is a perfect square. So basically, like how much element, like how, like which number should I have to add to the index 10 so that I can get a perfect square? So like I can make 10, I can add, like I can't make 10 to 9 because I have to add a number, not subtract. So I have to add 6 to the 10 to make it as a perfect square. I will not make it like, if I will not make it 25. The reason is that, like if I have to make it as a 25, like if I have to make a square root of 25, I have to add here a 15, and I can't add 15. The reason is that I have to add from these numbers. Okay, these are ai and these are I. So what I will do, I will add 6 here. So 6 is done. I have what I will add to 7, like what I will add to 9 so that I will get a perfect square. So I have to make 9 as 16. So I will add 7. 7 is cut. 7 will come here. What I will add to 8 so that I can get I can get 16 as a perfect square. I will add 8. Okay, 8 done. It is done. What I will add to 7 so that I can get a perfect square. I will add 9. It is done. What I will add to 6, I will get a perfect square. I will add a 10. It will also give me a 16. And now what I will add to 5 so that I can get 16. But you have to, now I have to add in an 11. But if you can see there is a like there is no 11 here. Like you can only use these number. Like basically you can only use these AIs. है ना? You can only use these AIs so that you can get the perfect square, right? So what you will do, so basically now I can't like, so basically now I can't make this 16, like make this, because I have to make it 16, I have to make 11. So I will try to make it a second perfect square, second smallest perfect square. The first smallest perfect square is 16, and the second smallest perfect square from the 16 is 9, from this, for this number. Okay, so I will add, I have to make it 9. What I will add, I will add 4. Now what I like, now what I will do, I have to make this 4 as a perfect square. 9? What I will add, I will add 5. I have to make this a perfect square. So I have to add 6. But now what you will see, you have used 6. What you have done, you have used the number 6 here. So now you can't add 6 here. The reason is you have already used it. So you can't make this 3 to number 9. So what you will do, you will now choose the another, like next smallest perfect square. So now what you will do, you can make it as a 4. So what you will do, 1 is used already? No. Is 1 come in this range? Yeah. So I've used 1. So I have also used both of this. Now I have to make this 2 as a 4, right? So what I will do, I will add 2. And now I have to make, I will use 3. So now I have to make 1 to 4. What I will do, I will add 3. And now what I have to do, I have to make 0 as a 4. But if I add 4 again, like if I add 4 here, what you will see, 4 is already used. 4 is already used. So what you will do, you will try to make another smallest. You will see the next smallest perfect square, which is 1. Now you will try to make 0 as a 1. But if you see, when you add 1, you will get a perfect square. But 1 is already used, also already used here, right? So you will now see the next perfect square, which is 0. So what you will do, you will add 0, and now you will get a permutation, which you can get a permutation which is added by the indexes with their indexes and get uh, a perfect square. Like if you see this gives us a 0, which is a perfect square. 1 plus 3, 4. 2 plus 2 4, 3 plus 1 4, 4 plus 5 9, which is perfect square, 5 plus 4 9, which is perfect square, 6 plus 10 16, which is perfect square, 7 plus 9 16, 8 plus 6 16, 9 plus 7 16, 10 plus 6 16. So this was my approach. I hope this is pretty clear to you. Like if this is not clear to you, you can watch the video again, and also you can comment your doubts. I will try to explain it, and I will now show you my submission. Right, this is my submission. This is accepted. Right, what I have done, I have taken an input. I haven't created an array. I haven't created and set. Like I have created and set so that I can maintain the like is 3 is like basically if you see in this example, uh, I have I need to when I have to make 3 when I am thinking to make a 3 as a 9, when I have to add a 6 here. Okay, but I have already used 6, so I can't add 6 here right now. So so to maintain this, what I have done, so to maintain this, uh, I have created a set. Now what I will do, what I have done, I have taken a square root of n minus 1. So like what is it, 10? So basically I have taken a square root of 10. So it will give me something about 3 point something. It will give me 3 point something. And if we will see, uh, I have to find the square root which is just greater than 10, which is just greater than 10. Okay, so I will take a square root. It will give me a 3 point something. And what I will do, I have taken a full value. I will take a floor value of 3 here. I have taken a floor value of 3. And what I have done, I have just simply implemented it. From I have implemented it in a reverse order. What I have done, if I have find it, like I have uh, like in the m, I have value 4, because like 4 into 4 16. So what I have done, I have just see if 16 minus 10 6 is present on the set. If this is false, whether if this is like if this is true, like if this is not present on the set, and like if this is on the range, if this number is usable, if this is in the range, I just have inserted it. And yeah, and I have just inserted it into the set. And I also have uh, like I have also set a of 10 equals to 6, right? And I have just implemented this. You can pretty see this, clearly see this. If you have still any doubt, uh, you can ask me on the comment section. I will try to explain you.